I wanted to show you one more example in section 3.5. We're graphing rational functions, and it's a difficult problem. There's lots of lots of different behaviors that a rational function can have, primarily around its asymptotes. So I just wanted to show you one more possibility here. In example 6, we have the function x squared minus 1 over x minus 1. And the first thing we're supposed to do is write this in lowest terms. And so if we factor the numerator, we have x plus 1 times x minus 1. And in the denominator, we have x minus 1. And so there's a common factor in the numerator and denominator, and it needs to be canceled out. So f of x is just x plus 1. What we're saying is that x squared minus 1 over x minus 1 is exactly the same as x plus 1 for all values of x except when x equals 1. What happens when x equals 1? At x equals 1, f of 1 is 1 squared minus 1 over 1 minus 1, which is 0 divided by 0. And the 0 in the numerator is interesting, but most important is the 0 in the denominator. Division by 0 is undefined. So whenever there's a 0 in the denominator, we say the expression is undefined. Or we say that the function is not defined at x equal 1. But if you look at y equals x plus 1, and you plug in 1, then you just get 2. So that's the difference, right? Again, everywhere else, the two expressions are exactly equal. And so f of x is exactly the same as x plus 1, except this weird behavior here at x equal 1. So how do we graph f of x? Well, we don't have to go through the 7-step process now, because look, all we have to do is graph the simplified form, x plus 1, which is not a rational function, and then just account for the special behavior at x equals 1. So to graph f of x equals x squared minus 1 over x minus 1, just graph the simplified form. And so that's a line. Let's see here. 1, 2, negative 1, x-axis, y-axis, and so if we're graphing x plus 1 when x is 0, y is 1. When x is 1, y is 2. When x is negative 1, y is 0. We can just connect these points up with a nice straight line. I got a little carried away there. I hope that's okay if my line runs through the formula. Okay, so this is x plus 1. Now remember, we're trying to graph f of x, so what do we need to do? We need to deal with with x equals 1. When x equals 1, our function f of x is undefined. And so all we have to do is just take the point at 1, 2 and turn it into an open circle. We call it a hole. So here is a hole at 1, 2. And what we've done is we've graphed the function f of x, and I'll write it out one more time. This is x squared minus 1 over x minus 1. And so you've seen holes before in graphs in chapter 2, and now you see a formula for a function that gives you a hole. And this is a nice example, and if you go on and take calculus, you'll see lots more functions like this as well.